now we're having our team who's presenting the card for assistive return using machine learning and scanning. I must mention this group or the project is funded by CREATE program. This program will support a number of health clinics for mental disabilities. So thank you.
Thank you, Professor. So, as she mentioned, we have the card for assisted return using machine learning and scanning. We are in the CREATE program. So, a little bit about ourselves. I'm John Tresca. I'm a team leader and working on the hardware. My interests are electronics and power electronics.
I'm Joel Thomas. I'm the part hardware, part software guy, and I'm usually mainly interested in doing the design for the system.
Hello everyone, my name is Jason. I am in the software hardware design aspect of the project, and I'm a computer engineer major, and my interests include computer hardware architecture, programming, and electronics.
My name is Frank Bicknell. I'll be working on the software development and machine learning.
So, our motivation behind this project was started after we met with YAI, the Young Adult Institute. They work with people with mental disabilities and help them find work. So from our meeting, they kind of explained to us what problems the people they support run into on the job. They said their biggest problem was confusion, whether it be on the task, the nature of the task, doing it right, and gathering other employees to help them finish the task, when it should just be a one-man job. So they also said that many of the people they support work in retail. So we wanted to focus on solutions to that problem in that field. So our idea was an assistive cart to streamline the return process. Through the use of a scanner, machine learning algorithm and database, and LED lights, we hope that this will eliminate all confusion in the restocking process and help people with disabilities maintain the restocking job.
So our main system is built on top of a shopping cart, so it's so easy to move around the store, and we can put the items that's been returned into the shopping cart. So this is our system architecture. Mostly, the scanner will scan the product's barcode, and it will be fed onto our database. It will sort the data according to the location of the item in the store, so the person who is operating the cart will be able to identify which item needs to be returned first and all. And all those data will be transferred onto the display. So because we are working with the mentally disabled people, we want our display to be so simple, so we'll have maps, guided information about the item that they need to return. So the map will show where exactly the item is located, and the side display will show which shop they need to return the item to. And once the card reaches the shop, it will send a signal to a microcontroller that indicates the light to assign which exact shop they need to put the product back into. So the hardware component we're using are a USB scanner. For a display, we're using a SunFounder 10-inch touchscreen. And microcontroller, we're using the Raspberry Pi 4 and the Arduino Uno R3 for the LED controls. We're using LED lights and a power supply. For the software side, we're using Microsoft Azure, Python, and MySQL. They're all working together.
Alright, so onto the software. I'll give a brief overview of MySQL. So MySQL is an open source free relational database management system. So it'll hold our data in tables in one big database rather than one big storeroom, kind of like one huge Excel file. It's scalable, reliable, easy to use, and it has integration with Python and Azure, so it's perfect for our project. So just to show the progress that we made a database called Supermarket, since we're working with retail. And we created 2 tables, one named items to hold our static data that's not going to change, and we have another table named user input, where I'll go over in the next few slides, where it's going to take in input from our Python code and put it in our user input table. And then from there, the 2 tables are going to compare with each other to see if the input barcodes that we scan exist in our items database type table. And then it's going to take data from our items table and put it onto our user input table. And then it's going to, the data is then going to be sorted by location number in ascending order. So just to give you a couple of screenshots, we created a table items up top there. And on the bottom, we have the input data to be put inside the items table. And this is just an overview of the MySQL program that we used. And moving on to Python. So Python is a clear, powerful programming language. It's very easy to use, has English syntax, and it's good for debugging and software development. And so with Python, it can run it anywhere. So for this project so far, we've been using Windows, but we plan on integrating it with Linux because that's also another open source operating system. So just to show progress with the Python side, so we got a connector package that allows Python and MySQL to connect together. And we created a variable mydb, and that basically allows us to connect physically our program source file and with MySQL database. And so continuing on, so we have the user input with the scanner, whatever they're going to return, and then it's going to be inserted into the user input table, and then it's going to hold all that data, and then once the user finishes scanning their barcodes, data from items table will be compared to what we have in the user table, the user input table. And then on the right there, that's the actual kind of the commands that we created that allows for the comparison of the barcodes that we have in items to compare to our input, our user input table. And then it's going to order by the location in ascending order.
So as Jason was saying, we're doing the sorting method like that. Originally, we were using a quicksort algorithm, but it didn't pan out in the end as we had issues like getting it to work in the end. It did sort it properly, but this was just an easier and better solution. So moving on to Azure. Azure is a cloud platform that can use SQL, virtual machines, app development. It can do so much. It's insane how much this program can do by Microsoft. So we're in the process right now of uploading our database onto Azure. And as you can see right there, there's 4 just like generic UPCs, like names of the brands and like cereals and everything, the price of it, and then the location. So the location is going to be in like ascending order from 1, 2, 3, 4, and then that's how the sorting method is going to work. It's going to go through that. So using Azure, we don't have to really go through the code. Once the base code is established, we can just simply go to this and just input. If you look at the top line where it says null for each one, we can just simply go through and keep inputting as many as we want. And we can even pass over like certain admin rights to another user, and they can do the same for their store. Now, with it being on the cloud, we obviously want it to be secure. So Azure offers transparent data encryption, and how this works is it's currently encrypting the data even as it's decrypting it. So me and Jason being the admins, it's decrypting it for us, but encrypting it for anybody else who's trying to access it unless we give them permission. And it's also like capable of decrypting and encrypting it without us managing anything. We don't have to do anything at all, it does it all autonomously. And then they use the bring your own key method. So this diagram shows how it works. So the security and the audit person, that would be us. Me and Jason would be managing the security keys, and we would be passing on the keys to encrypt and decrypt depending on who we give rights to access the database.
So these are these engineering standards that we're following. We're going to be working with EECE barcodes. We're going to implement Bluetooth next semester, and we're using the latest version of MySQL and Python, and we're using the latest version of the sort.
So our risk analysis, we needed to implement this product into a retail environment, so it needs to be safe for the employees to work with. We don't want them looking directly in the scanner laser or touching any power supply components that can hurt them. And privacy, as far as the database, we want third parties being able to interfere with the database and how we store and sort the items in the store.
For the cost part, we mostly have most of our money goes to the display and the microcontroller, and we plan to use the 3D printer for building the entire chassis. So we need a lot of equipment for that. That's why right now we have like $730. That's our cost right now. But considering we have this create fund, which would be $1,000, we are well under the budget.
As far as testing, we haven't been able to order much hardware. We have yet to secure the Create program funds, so this is mainly why most of the project has been software-based. But the unit testing involves the database working properly, being able to store and sort all of our units, and we were able to actually pick up a scanner and scan EECE barcodes. So we tested both of those, and those seem to be working properly. The integration testing involves barcode scanner importing the data into our database to be sorted. We tested that, and we had trouble with getting the text file that the scanner would create into the actual database so it could be sorted. But software figured that out with the use of sort and the SQL implementation. The acceptance testing, we are behind on that because we don't have the create funds. We have yet to order all the parts, so we can't fully implement all of the materials that we need to get a fully functioning product yet.
For the milestone-wise, we did most of the design part of it. So for the fall semester, we mostly doing the design part of the hardwares and mostly doing the software development because we don't have much fun to work with. So we did almost 80% of our software to be done and like 20% of the hardware. And during the winter break, we are hoping we'll be getting our create fund so we can purchase all the supplies that we need for the next semester. And we also plan to do the 3D printing during the winter break so we have time to build all those parts we needed. And during the spring semester, we are mostly focusing on hardware, so we'll be able to get our parts during the winter break and we'll be able to test it during the spring semester.
So future plans, we would like to finalize the power supply designs based on power requirements. The two boards we're using are pretty power hungry. We don't know the exact requirements that we need to power the microcontroller as well as the display. So once we have those components, we'll be able to see how much power they take and to design power supply around them. We also need to order the microcontrollers, so we need to be able to work with them, have our software side, understand how to use them, implement the connection to a database. And we're also going to create a mock store shelf with our LED lights to make sure that they're lighting up properly and that we're able to designate which LEDs are turning on to show the respective product. These are our references. Are there any questions? All right, thank you.